In Part D, we're asked to explain why the estimate we found in Part C, which is shown above there, differs from the actual value of the integral from 0 to 1/2 of e to the negative t squared dt by less than 1/200th. So, well, to do this, I want to go back to a few more terms and to them written in their general or abstract form, and to see that we have an alternating series. And we know that an alternating series converges when, first, when you have strictly alternating terms, which we do have above. Second, when the terms are getting smaller. And so when we use, again, x is equal to 1/2, we can see that the terms are definitely getting smaller. The first term was 1/2, the second term was 1/24th, the third term, when we plug in 1/2 to the fifth, that becomes 1/32nd, and times 2 is 1/64th. 1/64 times 1/5, which is 1/320. And so we can see that the terms are definitely getting smaller, and not only so, the limit of the nth term is heading for 0. So we know that this converges, and when the alternating series does converge, we know that its error, in addition, will be, the magnitude of the error will be less than the magnitude of the first unused term. And in this case, we use the first two terms for our estimate. So the third term, which would be 1/320, is the first unused term. And so the magnitude of the error in estimating has to be less than 1/320. And that is less than 1/200. So that demonstrates that. And that's all you have to do. So it's important, this idea of the alternating series, when it's going to converge, and its error and the magnitude of its error being less than the first unused term, are very important concepts here. Okay, so that wraps up this problem.